Hi guys, how are you all?
Good.
Good.
No, what? I was waiting for the others. I thought everybody will join and I can start. Algebra was what I thought. Dia is coming. Who else is to come? Why is. Okay. We will have 1.5 hours of class, right, today? Okay. How are you doing, Ritisha? What are they teaching in school for you?
Could you repeat that? I'm sorry.
What are you doing in school?
Um, we're on spring break right now,
Uh-huh.
and we just finished polynomials and like binomials and stuff like that, and then we're gonna be going on to what's it? Quadratic functions. I'm pretty sure.
Ah, okay. Okay. That's good to know. Okay. A couple of questions I wanted to. Today I was discussing some quadratic word problems. Before starting geometry, right? Can I go ahead and give it to you guys and see how you're able to do? Let's see. One second, I have them here. Hold on. Mm, yeah, give me a minute. How about this? Okay, how about this? If I ask you questions like this, would you be able to solve? This is on algebra, guys. It's an easy one though. See, and then I'll move on.
Miss Priya. Priya.
Oh, ow. Okay. Let's not do that.
This is a difficult question. Let's see. This one is a little difficult though, but a very common problem. First and the second problem. Try, guys.
What? Oh. Crap.
1 second.
Sorry. I think this is a little too much weight.
You're able to hear me, right, guys? No, I want to make sure I'm able to hear you. Can someone say hi?
Hi.
No, I'm not able to hear you. No. Again now?
Hi, Miss Priya.
Mm-hmm. 1 second. Sorry, Ratisha, once more. Oh, yeah, I'm able to hear.
Yeah, Miss Priya. I hear a violin in your background.
Hold on, I will mute.
Hi, Priyanti.
Oh wow. Wow, nice. Nice, Vishnuram. What is that? What is that you have answered?
Number 1.
No, you've given me an interval, right? What is that?
That
What is that you have posted? What is that interval I'm asking?
the point 1/4 or something. What interval you're asking for?
Yeah. What is that you have answered? 1 minute, ma. 1 minute. 1 minute. I'll be back. 1 minute.
Okay.
Interesting, Dia. Revenue problem you're able to do. Very nice. I didn't expect you guys to frame the equation for the revenue problem. Very nice, Dia. So, what is the best price? Best price and maximum revenue. Sham, that's good. Yeah. Very nice, Dia. Are you doing a lot of work at home, Dia?
I'm doing the stuff I get from school, and then I do like competition math, like practice.
That's nice. Yes, ma, Ritisha, that's correct. Okay, that's nice. That's nice, Vishnu, Ram, Sham, Dia. Swarit, I'm waiting for you. Vidyut, did you get it? Ashwik, did you
Yeah,
get
I
it?
just joined, so I just got my answer.
Yeah, I'm submitting my answer.
Yeah. See, in your group, I would think this is time based as well. Ashwik, did you get it? Yes, Ashwik. But Ashwik, they're asking for the interval, right? What is the other point?
Oh, okay, let me try something.
Yeah, both you need to give. There will be two places where it is at 64 feet. One is at 1 second and one is at 4 seconds. Okay, we'll move on. Who is not present today? I really want to know. Let me quickly check on that. Did you have any questions on last week's homework and all? If you have questions on last week's homework, this is the time to let me know. How was the challenge problem, algebra 1 problem set? I'm just wondering. Oh wow. We had the complete unit 16, right? I'm gonna try to submit homework. Come on. Yeah, Vidyut. Yes, Vidyut. But the second problem seems incorrect, right, Vidyut? You know why? Theatre charge is 15 per ticket, right? It sells 200 tickets, right? For every $1 increase. That seems incorrect, Vidyut.
Oh, I see.
You see the problem?
Yeah, I see it now.
Wow, sorry, that's right. So there are 8 fewer tickets sold, right? Vidyut, I'm just waiting for you. I think others got it. Vidyut. Yeah, Vidyut. So theatre charges 15 per ticket, but let's say they increase it by X dollars. What happens? So per ticket 15 plus X they increase, right? Uh-huh. Now 8 fewer tickets are sold, right? So that would be 200 minus 8X. So that will be the, so based on that you can calculate now. Vidyut, I'll move on. Ashok, did you get the second one? Yes. Okay. Ashok, that's correct. Okay.
My journal?
Can you show how to solve the first question?
First question you want me to solve? You're right. Yes, I saw that. Ashwik, I saw your answer, ma. Can I move on?
Can you just solve it so I know like how to do it
Which one do you want to do?
The first one.
First one, right? So, my rocket's height is modeled by this. So, the initial height is 0 for sure because that intercept is 0. So, initial height is 0. So, it is like this. This curve is like this. This negative sign indicates it's a downward facing parabola. During which time interval is the rocket above 64 feet? 64 feet is here, okay? But during which time interval is what they want, right? So now the height was 64, right? So equated to 64 minus 16t square plus 80t will be equal to 64. So when you solve this, 16t square plus 80t minus 64 will be equal to 0. You take out 4 as common. If you take 4 as common, minus 4t square plus 20t minus 6, right? Will be equal to 0. Again you can take another 4 as common, so minus t square plus 5t minus 4 will be equal to 0. Now when you factorize, you should get a 4 and a 5, right? Multiplication gets you a 4 and addition gets you a 5. So I can split it as 4t plus 1t, right ma? Minus t square. Now t is minus t plus 4. Then I take plus 1 as common, t minus 1 as common, so that gives you t minus t plus 4, right? So minus t plus 4. So this is 16 equal to 0. 16 equal to 0. Now what happens? Now with all this said and done, minus t plus 4 times minus t plus 4, wait. Minus t plus 4 and then t you're taking as common, right? So t minus 1. T minus 1. Let me write it down here. Minus t plus 4. T minus 1 will be equal to 0. So here you have 16. What else you have? That's it, right? Yep. Okay. Now that being the case, t can be equal to 4 or t can be equal to 1. So this is 1 and this is 4. Make sense?
Yeah. Can you also do like quadratic equation, please?
Which one, ma?
The quadratic equation.
The second one?
No, for like the first one.
That's
To
it.
solve for t.
Auntie,
Yes, ma.
is it fine if I did an inequality?
Absolutely okay.
I did
I
an
did.
inequality too.
Yeah, absolutely okay. It's okay to do an inequality. That's even better. But now my question goes back to Ashwik. What did you want, Ashwik?
For the first one, can you also do a quadratic equation to solve for t?
That's what we did now, right?
Okay. I thought you just did factoring.
What do you mean by quadratic? Tell me, what do you mean by quadratic?
Like the quadratic equation, like
This is a
negative.
quadratic equation, right?
Yeah, but like I mean like to solve for like negative b plus or minus square root. And then
Oh, yeah, quadratic formula.
Yeah, formula.
Yes, you can.
Okay.
Yes, you can. At some point, you're given the liberty. Okay, there was a stage when I said you have to do by this way, do by that way, because for you to get used to. Now you're given the liberty to do anyway.
Okay.
But yeah, you should know all though. Okay, can I move on now? Okay, shall we get started with geometry? I think all are here, right? Yeah. So, okay. Now, I want to get started with, we will go to constructions, okay? We will go to constructions, but I don't want to start with construction. So, I'm going to start with parallel lines, okay? Do you remember parallel lines, guys? Meaning angles in a triangle add up to what?
180.
Angles in a triangle add up to?
180.
180, yeah. Now, let's say you have a quadrilateral. Angles in a quadrilateral add up to?
360.
360. Okay, but before I get started, right, for geometric constructions, right, the book starts with geometric constructions, okay? Geometric constructions, I will use an online website to do the geometric constructions in class. You can also use that, great, okay? However, I really want you to get a protractor and a compass. okay, physical protractor and a compass to do it at home and check out. Okay, so many things you can do. Okay, geometric constructions, when I do it here, I'll use a UK website for us constructing and seeing. Okay, and you can also use, please make use of GeoGebra. GeoGebra is not limited to just geometry. Okay, GeoGebra you have to make use for algebra 1 as well. Anything, Pythagorean theorem, just type Google, go to Google GeoGebra plus Pythagorean theorem. Immediately you will have ton of links pointing you to explaining Pythagorean theorem in GeoGebra. So good a website. You should, everybody should try to, it's like Desmos calculator, right? Like that, go to GeoGebra for anything. Okay, so it explains it so beautifully. Okay, any concept you can visualize and see, that's the best part. Okay, for constructions we will do online using a website. You can as well do it, so there is absolutely no problem even if you don't bring a protractor and a compass. However, physically I want you to buy a protractor and a compass at least next week. Okay, so now coming to a quadrilateral, what is the sum of the angles in a quadrilateral?
360.
360 how? Thanks.
Because each angle is 90, or like
Each triangle, it can be split into two triangles, and two triangles make up 360 degrees. So all these three add up to 180 degrees, these three add up to 180 degrees. So total angles in a quadrilateral add up to 360 degrees. How about a pentagon? A regular pentagon, let's say. For that matter, even if it is an irregular pentagon, what is the angle? Sum of the angles.
540
How do you know?
because there's 3 triangles.
Good job. 3 triangles. Is there a formula for it?
Yeah, I'm pretty sure.
180
Yeah, what is
times n
that?
minus 2.
So triangle,
180 times n minus 2.
good. Triangle, number of sides and number of triangles, sum of angles, and then each angle if it is a regular polygon. Regular polygon means the sides are all equal, right? So in a triangle the number of sides is 3, number of triangles is 1, angle sum is 180, each angle is 180 by 3 if it is regular. For a regular polygon this is each angle. Okay, now coming to quadrilateral, what happens? Number of sides is 4, number of triangles is 2, 360, here 360 by 4, right? So I will write it out as 180 times 2. Okay, right? So number of sides will be n. Okay, now I can write this one as angle sum by, I will write this as 180 times 2, right? 180 times n minus, this is 180, okay, times 2, this is 180 times 2 divided by 4. Now, one second. Okay, now for a pentagon, right? Number of sides is 5, number of triangles is 3, 180 times 3, this one becomes 180 times 3 divided by 5. Now for a hexagon, right? Hexagon, right? Number of sides is 6, number of triangles is 4, 180 times 4, 180 times 4 divided by 6. Yeah. For a n-gon, number of sides is n, number of triangles is
n minus 2.
n minus 2 times 180. For a regular n-gon,
Is n minus 2 times 180 over n.
Yep, n minus 2 times 180 by n. Makes sense? You have to remember this formula. That's why I'm saying. Okay. Okay. Now, we discussed only the internal. We discussed the sum. I just barged into geometry directly. Okay. I think it's okay for us. Okay. The sooner we complete, the sooner we can move on. So, basically, the sum of all of these angles is what we are discussing. But I have a question to you now. Okay. Let's see this one. You know a triangle, okay? Okay, what is the sum of the exterior angles of a triangle? I'll wait for you, okay? Think about it nicely and then tell me. You have to prove. If you say something, then you have to prove. I'll ask you to prove, okay? You cannot just Google and tell me the answers because there's no way. You'll have to prove. If you say something, then you'll have to prove. So what is the sum of the exterior angles of any polygon? How to calculate that?
Hey, Auntie, I
Yes, ma. Tell me.
have a question.
Yes.
Would the exterior angles just be this, or would it be like the entire thing, like all the way around this, like that?
First, the number of exterior angles for a triangle is 3. Number of exterior angle for a quadrilateral is 4. Number of exterior angle for a pentagon is 5. So there are 5 exterior angles. I am talking about the sum of all exterior angles in a polygon.
Okay.
Let's try.
Wait, do we put it in chat?
You can shout out, ma. This is just concept, right? Go ahead.
That's 360.
Why? How? Did you Google?
No, I didn't. I know this, but
Okay, good. How did you know?
well, I think I remember it, but it's like 360 divided by n, and n's like the sides. But I don't know if that's it.
What I did, so you see how it's like a straight line if you
That's
look
what
at
I did.
Well, yeah,
so
that's
that
it.
adds up to 180. If you just do 180 divided by 3, you can find the interior angles, which is 60 for each of them, and then 180 minus 60 is 120, and then you add 123 times to get 360 on
Oh
the
wow,
other.
nice, nice. So see,
But that's
1
for a
plus 2,
triangle.
that's what you did. Okay, 1 plus 2 plus 3 is 180, right? Now we all know 3 plus 4 forms a straight line 180. 2 plus 6 forms a straight line 180. 1 plus 5 form a straight line 180, correct? Now let me add all of the angles together, meaning I'm going to frame an equation like 1 plus 2 plus 3 plus 4 plus 5 plus 6. Add up to what? 180, 180, 180. 180 times 3, right? 180 times 3. I don't want to multiply right now. Let's see. So now what do I know? What do I know now? For now, I want to know about 4 plus 5 plus 6, right? This 4 plus 5 plus 6 is what I want to know, correct? Okay. 4 plus 5 plus 6 is what I want to know. Here, when you add all of them together, right? 1 plus 2 plus 3 is 180. So, subtract that 180, this becomes 180 times 2. So, 4 plus 5 plus 6 add up to 360. Does that make sense here? 4, 5, 6
all of
add up to
them.
360.
It's for all of them.
Yeah, how? Why? Same
Because-
thing, right? Same concept applies. Yeah, go
For
ahead.
a quadrilateral, it's 90 on the exterior angles times 4 is 360. And for a pentagon, the exterior angle is 72
Correct.
times 5 is 360.
Good job. So for all of it, right, you think about 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 will add up to what? 180 times 4. Okay. But the thing is 1, 2, 3, 4 already adds up to 180 times 2. So this becomes 180 times 2 again. 5, 6, 7, 8 add up to 360. Make sense? So exterior angles in any polygon, when you add up, it will add up to 360 degree. Make sense? Okay. Now, I hope you all remember this parallel lines and a transversal. Do you all remember? What do you remember about the parallel lines? Do you all remember?
Alternate interior angles are the same.
Yeah, what are these type of angles?
Congruent?
Yeah, 1 and 2 are congruent. That is true. But what type of angles are they?
Cute?
Huh? Those are not acute angles. Yeah, those are acute angles, but that's not their name. Name is what I mean. Huh?
Corresponding.
Oh, correct. Corresponding. I didn't expect you to remember. They're called corresponding angles. So this is the symbol I'll use for congruency. Okay, if I say two triangles are similar, I'll use this. This is the symbol. Amma, when we come to geometry, every week we will get introduced to new symbols and new definitions which you should be aware of. Okay, this means congruent, that means similar. Okay, now 1, 2 are corresponding angles, same position, right to the right side of the transversal, up of the parallel line, same position means corresponding angles. Can you name any other pair of corresponding angles, Anish?
1 and 7.
No, 1 and 7 are not corresponding angles, right?
Mm-hmm.
The position should be the same, right? 1 and 2 are corresponding angles. What else?
Oh, I can't. 4 and 3.
4 and 3, correct. 5 and what are corresponding
Wait,
angles?
I thought you said it
7.
could 5 and 7.
5 and 7. 6 and 8 are corresponding angles. Corresponding angles are congruent. Okay. And one more thing, this geometry with lines, points, all this we are studying, right? This we are doing it from the mathematician Euclid. Okay, whatever we are studying is Euclidean geometry. Okay, whatever we are studying is Euclidean geometry. So, is there any other geometry? Yes, there is. There is something called spherical geometry. Okay, everything is a sphere. Okay, there everything is a sphere. Okay, here we have lines, right? Points, planes, all this we have, right? There they have only sphere. Okay, in sphere, you know what are the lines? Lines are replaced by great circles. You draw a circle around, that becomes their line. The line equivalent in spherical geometry is called great circles. Okay, there are two geometries. One is Euclidean geometry, one is spherical geometry. We are following only Euclidean geometry. Okay, spherical geometry is entirely different. Everything is a sphere. There, our lines are replaced by spheres, and there are so many differences between Euclidean geometry and spherical geometry that we'll see later. It's not in the book, but I really want you to know, because whenever you study geometry at school, this is a subtopic that you need to definitely know. Okay, so as and when time comes, I'll keep pushing inputs on the difference between the two. So basically, here there are lines, planes and points, right? There it's everything is a sphere. You have triangle, right? There you have triangle. Yes, there also you have triangles, but the thing is, here three lines meet, right? That forms a triangle. So there, when everything is a sphere, right, what would happen? The sum of the angles in a triangle is 180 is what we are saying, right? But there, if everything is a sphere, and I am saying the great circles represent lines. When I say that, right, automatically the meeting points of the great circles, right, becomes the meeting points of great circles represent triangles, right? So what happens, you see, what happens here? I have not drawn a super nice triangle. Okay, I just want to erase this. I'm not doing a good job. Wait, let me cut it out and show, because I want you to visualize that nicely rather than me drawing it up and making a mess. Spherical geometrical triangle. Okay, this is what I wanted to know. Yeah, that's better. I want an image that shows the intersection. Yeah, see, this is a good one. Yeah, this one shows it so nicely. See here, do you see? In spherical geometry, see the intersection of three great circles, okay, that form the triangle. You know what happens here? When you look at the great circles intersection forming a triangle, right, the angles do not add up to 180, but the angles add up to more than 180 in spherical geometry. Make sense? So these are very subtle differences, okay, but please understand that there is something called spherical geometry.
Priyanti,
Yama?
do you learn trigonometry and geometry?
Oh yes. Yes, we do learn trigonometry in geometry. By the way, did we study 30, 60, 90 and 45, 45, 90 triangles earlier? Did
Yeah,
we
we
do?
did.
We did as a part of the class, huh?
Yeah.
Yeah, I remember learning about it. I'm pretty sure it was from this class.
Oh, nice. Okay, that's good to know. Then pre-algebra we learned. Oh, that's good. Okay. That again comes as a part of geometry, but everywhere you'll use if you're participating in competitions as a part of geometry, everywhere they'll use that special triangles, special right triangles, 30, 30, 60, 90 and 45, 45, 90. Okay. So now we'll come back to this. We talked about corresponding angles. How about the alternate interior angles? Do you all know? What are the alternate interior angles? See, why I am asking you is we have studied this in 7th grade. I'm trying to revise.
2 and 7?
2 and 7. Yes, 2 and 7. So they are congruent too. Okay, another pair. Somebody else. Can somebody else point me to alternate? See, one thing is this side, this side. If it is same side means you call it as same side. Okay.
1 and
If it
5.
switches means alternate.
3,
1
6.
and 5. 1 and 5.
Yeah, 1 and 5 can't. Alternate, oh, Amma, alternate interior. Interior means this. This is exterior.
And then 6 and 3.
Yeah, 6 and 3 is good. Alternate interior angles are congruent. Very nice. Now let's go to what? What else I can go to? Alternate interior angles and then alternate exterior angles, let's say. What are the alternate exterior angles?
1 and 5.
4 and 8, 1 and 5. They are congruent. Any questions still here? What is 2 and 6 called? See, first let's discuss all the congruent ones. Okay, we discussed corresponding angles, we discussed alternate interior, alternate exterior. Yeah, that's all, right? Yeah, that's all. Now let's go ahead and discuss all the supplementary angles. Okay, supplementary angles means, what about 1 and 8? What are they called? What about 1 and 8? 1 plus 8 will add up to
180.
180. Why? They form a line, right? Can I call them as supplementary?
Yeah.
Can I call them as supplementary? When they add up to 90, what are they called? What are the angles called? What are the angles called when they add up to
Complementary or something.
Complementary.
complementary? Don't forget, guys, that's what every geometry class will introduce you to different definitions. You should know. Complementary means angles that add up to 90 degrees. Two angles that add up to 180 degrees called supplementary angles. What is the supplement of 10? What is the supplement of 10?
170.
170. Good job. What is the complement of 80?
Not 10.
Not 10.
10. So you need to remember, what is the complement of 35?
65. And
55.
55.
Yeah, so complement of 35 is 55. So they both add up to 90. So supplementary means they both add up to 180. Okay, remind me, we have to do some problem. See, some of them are not in this book as well. So I'll go ahead and give you some word problems with complementary, supplementary. I want to give it today itself because the book introduces you to a lot of definitions related to the whatever we are discussing at the start of the book. Okay, but we don't have problems on supplementary, complementary in the book. So let me work on that as well because that comes as a part of your school geometry. Okay, now this 1 plus 8 we did. Okay, how about 1 plus 3? What type of angles are they called? 1, 8, 1, 3. What are they called? Can I call them as linear pair hereafter because they form a line? Anish, are you with me?
Yeah.
Can I call them as linear pair because they add up to 180 degrees as well? They form a line, right? So they are called linear pair. Can one of you name another pair of linear pair?
2 and 4.
2 and 4. Another one, somebody
8
else?
and 7. 8 and 7.
3 and 7, correct.
5 and 7.
No,
Wait.
8 and 7. 8 and 7.
8 and
Miss
7.
Priya, I have a question.
Yes.
6 and 5.
Would 5 and
2,
8
4.
technically be a linear pair because they do add up to a line?
Which one?
5 and 8, would that be considered a linear pair because they do add up to
They
a
have to
line?
make a half moon, ma. 5 and 8 are far apart. So they are not
they
linear.
have to be next to each other. Okay. That's
But
not
yeah, 5 and 8 are See, I'll come there. 5 and 8 has got something else, some other name. But when it comes to linear pair, they have to be together and should make up a line.
Okay, thank you.
Make sense? Yeah, I'll come there. 5 and 8 I'm going to discuss. Okay. So the next one after this is I'm going to go to same side interior angles. What are they? They can also be called consecutive interior angles. Two names are there. Same side interior angles or consecutive interior angles. What are they? Think about the name. Same side interior angles. I've already given what same side, what's alternate, what is interior, what is exterior. I'm asking for same side interior angles. Anybody can call out. You can make mistakes.
2 and 3.
2 and 3. Good job. 2 and 3. They're called same
6 and 7.
6 and 7. Correct. Now what is that other pair then? We discussed same side interior angles. So what is that the other pair that we can discuss?
Outer interior angles.
Same side exterior.
Yeah, exterior.
Same side exterior angles. What are they? They will also add up to 180. But what are they?
1 and 4.
1 and 4. That answers Ritisha's question as well. What is that? 5 and 8.
8 and 5.
Yeah. So that is same side exterior angle. They are supplementary too. So we discussed a lot of this now. Corresponding angles, alternate interior angles, linear pair, consecutive interior angles, consecutive exterior angles, or same side exterior angles, and the last one I forgot in this set. Completely I forgot. What are vertically opposite angles? What are vertically opposite angles?
4 and 1.
4 and 1. They are 4 and 1 now. Vertically opposite angles. Vertically opposite angles should meet at a
4
X
and 8.
point. Huh?
4 and 8. I know 4 and 6.
4 and 6. Vertically opposite angles should meet at an X point. 4 and 6, 2 and 5, 7 and 1, 3 and 8 are all vertically opposite angles. Can I move on now? Can I move on? Are we good? Okay. Now I'll ask you a lot of questions now. So the concept on parallel lines is good, but you can be asked a ton of problems. Let's see if I can get you that. Okay. What I want now. First I need to do this, then I'll do, let's see. Yeah. How about this, guys? Would you be able to solve this? This is hard. Okay. How about this? I will show you how to copy a segment today. Maybe that part of construction we can do. Okay. I talked about vertically opposite angles. They are also called vertical angles. Okay. But before we move on more, right, I really want to understand points, lines and planes. You know what is a point? You know what is a point?
Yeah.
Okay, I'll come there. Okay, let's see this one. How about this? Okay, let's see this. Are you able to answer? Let me know. Try that. See, this is just comprehending. Supplementary is the only word you might not know that we have explained. Okay, what this entails is your comprehension skills. Read the problem, comprehend it, write an equation.
Miss Priya, I sent my answer.
You sent your answer.
If you can help me do my homework, yeah, sure. Huh?
Wow, very proud of you guys. Ritisha correct, Shyam correct. See, that's the advantage of doing this class. Usually it takes a long time for me to go through these problems.
You know what I was thinking about today? Because
I sent my answer.
1 second, I'll check.
I don't know if
Vidyut, can you check Vidyut?
you're gonna be what?
Yes, everybody got it right.
No, you're not.
Vidyut, please check. You are in a hurry.
I see.
See,
Yeah.
it's just that you need to, every time before telling the answer, just go back to the question, read and see whether
Do the easy question.
it matches your equation. That's a big thing. Okay, how about this?
I put the answer after evaluating 2x plus 4, and that's why.
Oh, I see. 1 second, guys. Okay, let me go ahead and give you 1 or 2 more questions on this and then we'll move on. It's good to see. Yes, Vidyut. See, the thing is, it's not like we don't know. The thing is, we are very just like that, it's very fast. Okay, let's see. I want to give you some. Let's see.
Listen to me.
I want a hard one.
Do you feel like you have a lot of work? Huh?
Oh, wow. Okay, I'm going to give you this. Let me see whether you all remember the algebra part of it.
Here. Can you go get your phone?
That's a good one.
I'll bring snacks for everybody. Here. I'll bring snacks. No, no, not.
நான் வேணா போட்டு தரேன்டா.
Milk separately? Yes. Okay. Here. Here, buddy. I'm sure that ready for now.
Oh, wow.
Go. Bye. Here,
Square of the
I need to ask Amma about a couple of things for college. Be careful. You talk to Amma.
Miss Priya,
Sorry guys, I'm here. Go ahead.
I sent my answer.
Nah, Amma, alright.
Is that Amma? I'm checking ma. Wait, Amma. I saw your answer. Wait, I missed. The angle forms a. Okay. So what is the common difference? Is it right, Amma? Complement of an angle itself, and the supplement of an angle. Is it right, Maratisha?
It's the only thing I can think of based on what I wrote. Or I'll just wait until you explain it.
Maybe you are right. I don't know. I didn't get that. Let's see. We'll do it and see. Yeah, Ashwik seems right. But I want to make sure. I don't know. Let's see. Should I do, guys, or should I wait? Did you get it? The measures of a complement. Suppose the angle is x. Okay, complement of the angle is 90 minus x. Angle itself is x. And the supplement of the angle is 180 minus x. So they are in arithmetic progression, means they have a common difference. X minus 90 minus x. That's the common difference. 180 minus x minus x. So x minus 90 minus 2x will be equal to 180 minus 2x. Right? So that would be minus 90 minus x equal to 180 minus 2x. Right? X will be equal to what am I doing? X minus 90 minus x. Oh, see. 1 second, guys. What a mess I made. 1 second. This will be plus x. 180 minus 2x. That's correct. So here it becomes minus 90 plus 2x will be equal to 180 minus 2x. That's correct. So 4x will be equal to 180 plus 90 is 270. So
Isn't it plus 2x?
did I make a mistake? Where?
Yeah.
Ma?
Isn't it plus 2x here?
One second, did I make a mistake? Hold on, minus 20 plus x, right, ma? Why plus 2x? This x is here, huh?
You'll get x squared minus 90x plus plus x.
Wait. What is x squared? Where? Common difference, right? X subtract 90 minus x, right?
But then when you x minus 90x.
What is x minus 90 minus x? When you distribute the negatives, you got it, huh?
I was thinking of this step, my bad. Like the third step, my bad.
No problem at all. Okay, it's okay. Whoever, we'll correct each other. No problem. Minus 90 plus 2x will be equal to 180 minus 2x is what I'm getting. After that, I have 4x. Will be 270. I don't know. Something else I'm getting. Let's see. What is this? What is the common difference they're asking? Okay. So x will be equal to 4 5s are, no, 4 6 are 24. 3 6 are 30. 6 4s are 24, 30. So, that's so bad. So, 4 6 are 24, 6 are 24, 3 30, 7s are 28, 67.5. X will be equal to 67.5. Then, what is the common difference is what they're asking, right? So, 90 minus 67.5 is what? 68, 78, 88, 22.5, right? So what is the common difference? Common difference is 45. Make sense? Dia, are we comfortable with this?
Yeah.
How about Anish? Are you comfortable with this?
Yeah.
Yeah. Sometimes, see, these word problems can become very tricky. Okay, but let's see. How about this? 50 more than this. I would like to do this. Solution t minus x will be equal to 90 minus x the whole. One second, guys. T minus x will be equal to, so it's 40 more than, I don't know. I just want to do this and see. How about this? No, I don't want to. How about this? Okay, this one is an easy one. Why don't you try this one? You try this one, I'll give you a harder one. That one is an easy one. What is the measure of the complement of the smaller angle? It's 40 more than, let me do it and see before I give it to you guys, because I feel like measure of an angle supplement is 40 more than the square of the measure of its complement. The square of the measure is 40 more than the square of the measure of its complement. Okay, find the measure of the angle. The measure is an integer. Oh, wow. It's a hard one.
Miss Priya, is that my answer?
Yeah, ma'am. Yeah, Ashwik, that's right. Ritisha, correct. Swarit, I'm waiting for your answer. Diya, I'm waiting for your answer. Yes, Shyam, that's correct.
Wait, I have a question.
Yeah, go ahead.
Like, basically, you gotta multiply x or something? Like, what do you do?
Oh, yeah, sure, Anish. We can do it together. Angle P and Q are supplementary. What does it mean? P plus Q is 180 degree.
Yeah.
Measure of P is 5x plus 10. Just plug in. Measure of Q is x plus 2. Right? They're asking to find the measure of the complement of the smaller angle. Okay? So that will be, first let's find the angles. Okay? 180. Now 6x plus 12 equal to 180. Okay, 6x equal to 180 minus 12 is 170, 168. X will be equal to 6 or 12, 6 8s are 48. We know this. Now what are the angles? Definitely this is the bigger angle, correct? So let's find only the smaller angle is 30. What is the complement? 60. You got it?
Oh, so like, yeah, I see. Okay.
It is just, yeah, these are all only comprehension skills. Okay, most of the concepts you already know, but how you comprehend and put it into an equation is what really matters.
Yeah.
Okay, yeah, let's try this one. Can we try this? I don't know. This is all, yeah, I have not meaning. Usually in the school, if it's a school based geometry, I won't work to this, I won't go to this depth. How about this? That's interesting. I just want to do this. Oh, wow. Okay. Yeah, I'll give you one very different question. How about this? This is a nice question, but I don't know how many. Yeah, let's try this one. This is the trickiest part. Okay, did you guys get the other one? Okay, this is the second question. I'll put it as 1 and 2 so that I understand when you send the answers. It's fun, right? This one. Yeah. Dia, I'm checking your answer, ma. Wait, ma. Yeah, Dia. Perfectly nice, Dia. Ashvik, that's correct. Ritisha, that's correct. Vidyut, nice. Vishnu Ram, very nice. We'll go ahead with the second. Second one is a little hard, guys. If it's hard, I'll help. But it uses proper algebra. It uses proper algebra. Shall I do it? Meaning it's very 2-step or 3 steps only, but you will have to use some strategy.
Can we try it first and
Yeah,
then
sure. It's a nice one. But the class runs fast.
Miss Priya has my answer.
Oh, fine, nice. How did you do that, Ratisha?
I squared the supplement and then minused it from the square of the complement. And then
Did you do
equaled it
this?
to 1.
Did you do this?
My bad.
That's what
I
I'm
did it the other way. I did
That's
x
what I'm
minus
doing.
180.
Difference between the square of the supplement and the square of the complement. Did you do this, Ratisha?
I think I did. Oh, I did I make a mistake? Because I did x minus 180 and x minus 90 instead of 90 minus x and 180 minus x.
Yeah.
Priyanti?
Yes, meaning coming to the definition of supplement complement, that is incorrect. However, they are squared, right? So it should not produce a much of a change. You see what I mean?
Yeah, I'll remember that because whenever I think of supplement complement, I always end up doing x minus 180 instead of 180 minus x.
180 minus x is correct.
Okay. Yeah.
But did you get it? This is difficult, guys.
I feel like I'm getting no solutions because the x squared terms cancel.
X squared terms cancel. Let's see. Are you doing this with you? You don't have to do this actually. You don't have to do this. Yeah, x squared term cancel, but the x term is there, right? You will get a solution. X squared terms cancel here, but a minus b the whole square is 2ab is there, right? 360x is there, and then here you have 180x, right? See what I mean?
Oh, I see. Never mind. I'm doing
but with you, yes, that is one way, but that's a little roundabout way. The easiest way I'll tell you. Okay, take supplement as S, complement as C. Okay, there are only two variables. The difference between this.
It's a difference of squares?
It's a difference of squares, yes. So you get S plus C, S minus C, right? This is an algebraic formula. If you do this way, it's just 3 steps. Okay, supplement of an angle, complement of an angle. Think nicely, okay? Supplement of an angle, complement of an angle. What happens when you add them together? Let's subtract them together. What is the answer? Any angle, supplement and complement, meaning so I'm subtracting. Yeah, 90. So when you subtract this, by automatically this is 90. Right? Now, what is S plus C? 180 minus X plus 90
270 minus 2x.
270 minus 2x. 270 minus 2x will be equal to 18900, right? So that's easy. Now, this is also easy. Now,
Wait, Miss
minus
Priya,
2x.
can I clarify something?
Oh, it's 30.
Yeah, go ahead.
On the bottom, you wrote that 180 minus x plus 90 minus x. Isn't it minus 90 plus x? Because the minus.
This is, okay. This is the difference of them. This is the sum of them, right? Okay.
Oh, okay.
I should have
Alright.
clearly done. I should have clearly done.
No, I apologize. I thought
No
you were.
problem, ma. No problem. No. I should have clearly written down rather than combining. This is the sum of the complement. This I did it for s plus c. This I did it for s minus c. Make sense?
Oh, okay. Yeah, that makes sense.
Yeah. So, okay. But 1 minute, guys. I just want to check with the key as well because I don't want to make a mistake or mess you up with this. Yeah. 30 is on. 30 is what we got, right? Yeah. 30 is correct. 60 x equal to 30. Makes sense. This was a different problem. That's why I thought I'll bring it up. See, the difference in square is a treasure in mathematics. Okay, sometimes supplement and complement, when you add them, subtract them, it's always 90. Remember that. Can I move on? Wow. Vishnuram, you got it already before I sent it? Wow.
Yeah, but I
Sham,
kind of did it different way than that.
how did you do it? Can you educate us? And same with Ashwik and Sham. Go ahead.
I did the longer way than that.
Oh, longer way. Like you use the quadratic equation. Meaning,
Yeah.
quadratic x square will get cancelled, but then you got the bigger equation. Okay, great. Shyam, how about you?
I kind of like guessed using like the
Okay. Guessed means what equation did you frame? Like 180 minus x the whole square, like that?
yeah.
Oh, okay. How about you, Ashwik?
I did like I just rewrote like 180 minus x minus 90 minus x like 2 times to remove the square.
Oh,
And then I
okay.
did the first bracket was 180 minus x minus 90 minus x equals to 90.
Nice.
And the other bracket equals to 270 minus 2x. And then I solved, and then I got 30.
Nice, guys. Nice. Okay, now let's go ahead and try this one. And one another thing, right? Meaning, just browse through colleges and see, guys, which are the colleges you would like being in. So, like that, if you have if you have some analysis earlier, right, it helps later in your high school. Look through colleges, state colleges, public colleges, private colleges, all that. When you have a look at them, when you read through, you have to go to each college website and what is their theme, what they stand for, or what are their values. Do you fit in? Is that what you want? All that, if you can go through them and then understand, oh, this is a place where I want to go to. Like that, if you start having some ideas, right, it really helps later. See, it's after all on you, right? Meaning it's very difficult for parents to help you make a decision. You will have to take the decision, right? You will have to go through the college. Oh, is this a place I want to go to? Do I fit in here? All that you can analyze for yourself. Maybe for 10-15 colleges you can analyze and see. And then when you make the list for colleges later, it really helps. Okay, that's a homework. Remember, whenever you are free, right, don't go to YouTube. Maybe for 20 minutes, don't go to YouTube, do this. So it will really help later. Slowly it adds on, right? In 1, 2, 3 years, right, you will have a list of nice 10 colleges to apply to. Because otherwise, if you accumulate everything towards high school, you will not have time for anything. Because 9th, 10th, 11th, 12th, it's so demanding. So you won't have time for all these. Now when you have the time, you can look through. You don't have to make decisions now. You can look through, oh, this college really wants this. Am I in it? Or if I want to go there, then I'll have to fit myself in this sense. I would like to, what you do, does it match? All these things you can do. Okay, it's just an idea. Okay, now I really want to go over. A point is this. This can be referred by a capital letter. Okay, And then what is this? What is this? What is this? Do you all know?
It's a line segment, an array, and I forgot the last one.
This is a line segment. This particular class, I'm really interested that you don't refer it incorrectly and stuff. Okay.
Isn't the last one technically just like a line?
Yep. Ray, how do you represent this? Line segment is like this.
And isn't there like a line, like an arrow on the top
Yep.
of my array?
Yep. Makes sense? Goes on forever. And when two lines are congruent, I mark it like this. Makes sense? When two lines are parallel, we use this. Any questions on that? Okay. Now, let's say there's a line segment AB. If I say M is the midpoint, right, I can mark it like this. Instead of saying M is the midpoint, I can say that these two segments are equal. Any questions on that? What are collinear points and concurrent lines? What are collinear points and concurrent lines?
Are collinear points like points on the same line?
Yeah. These are collinear points. Three non-collinear points define a plane. Do you know that? How do I say that? It's not like, no, I'm not saying it right. Just a minute. Three non-collinear points don't define a plane, but there's something related to that. Hold on. Yeah, correct. The way I said was correct. Three non-collinear points define a plane. If 3 points are yep, 3 non-collinear points define a plane. What is that? I want to show you what is that as well. Hold on. Yeah. Yeah. Why do 3? I really wanted to show. See, 3 non-collinear points define a plane. I can show a nice image of that. See, this is a 3D picture. See here. This is a 3D picture. Do you see? So here, if you have, meaning, how do you define a plane? 3 non-collinear points can define a single plane. Make sense? Plane is a flat surface. Does that sound good? Okay. These are important, guys. 3 non-collinear points define a plane. Okay. Now let me go back. Plane is a flat surface, I have told. Coming to ordinary circles, right? Yeah, you all know already circles, but there are certain aspects of circles that you don't know. Here, circle with center O. How do I specify it and write down? Circle with center R. This indicates a circle with center R. Make sense? So this is called, you know what is it called, right? Radius. You know what is a diameter. Diameter is the longest chord. Oh, first, what is a chord? This is a chord, right? Diameter is the longest chord of the circle. The area enclosed by 2 radii and the outer part of the circle is called what? The area enclosed by 2 radii and the outer part of the circle, what is it called? Segment. I'm sorry, sector. Okay, now the area enclosed by a chord and the outer part of the circle, this is called a segment. Make sense? This is a sector. Okay, this is a segment. Any questions? You know what is the perimeter of a circle called?
Circumference.
Yeah.
Circumference.
What is the formula for that? 2 pi r or pi d. Correct?
Pi
How,
d.
how many diameters can fit into the circumference of a circle?
Like
Oh,
infinite.
Pi.
yeah, pi. How many diameters can be in the circumference of a circle? Ritisha, did you get that?
Yeah, I
Yeah.
got it. My bad, I was confused
No,
at
no,
first.
not a problem at all. Okay, this way, meaning for me to make sure everybody understands, it takes a long time, but here it's very easy for me. So, how many diameters in the circumference? It's pi times d, so pi d, meaning there are 3.14 diameters in the circumference of a circle. Now, the area of a circle, do you know why the area of a circle is pi r square? Have you seen that? Why it is pi r square?
I don't know.
Because like the radius like to the power of 2 and then pi, so like then the circumference or something.
Have you seen the video, guys? No?
I think I've seen this like one video or
Yeah, why is it pi
it was
r
like
square?
Did they split into triangles?
What
I
is
don't
it?
know how to describe it, but I've seen the video where they like it's like a whole circle and then they make multiple and then finally when it's like there's
Like
3.14 lines, it becomes a solid rectangle or something like that.
Exactly. Yeah. How do they split it? You have seen, huh?
Yeah,
triangle
I think
it
so.
or something.
Nice. I really want you to see that very well. Let me see. Let me
Do
see.
like split into like really, really small triangles and it's
Yeah,
all like a rectangle and then
Yes, ma'am. See
they
here.
split into like eighths, then sixteenths, and then like something.
Yeah, I can show you
And then
the. I
they
can,
like do into three.
yep. You should remember this. Why is it called pi r square? We just like that learn in 7th grade. Oh, the area is pi r square. See, let's say you split this into What are these called again? What are these each called? Just now we learned.
sectors.
Sectors. So each is a sector. So we put that, we cut out that circle like this. See, the triangles 1, 2, 3 are here. Okay. This sectors 4, 5, 6 are here. So you put it like this. Okay. Now the thing is, what you do here, this forms literally a parallelogram, right? So what you make out of it here, this is R. Basically, this is R. When you think about it, this is R.
I learned that like the base of the parallelogram is like half of the circumference.
The base of the
The parallelogram that you make with the sectors.
sorry, Mashuk, what is that?
The parallelogram on the bottom, its base is like half of the
Circumference, correct. Because the blues all form, see this one, this one, this one, this one, this one, sum of all these, right? Sum of all this is the base, right? So basically, the circumference is 2 times pi times r. So half of it is pi r. So this becomes pi r and this becomes r. It's a parallelogram. Okay, what is the area of the parallelogram? Pi r times r, which is pi r square. Got it? Okay. Let's move on. That's how area of the... and I did not finish the circle. We just went off. Detoured. How about a line that touches a point on the circle? A line, yeah, that touches a point on the circle is a tangent, and it is always, always, always perpendicular to one radius of the circle. Okay, tangent. And you know what is a chord, okay? But what is this line called? A line that touches the circle at two different points is called a secant. Goes through the circle is called a secant. Okay, these are, and what are, okay, I asked you but we didn't discuss this. What are concurrent, can you draw 3 concurrent lines? What are concurrent? What are 3 concurrent lines? What are 3 concurrent lines, guys? These are concurrent lines. What are three concurrent lines?
3 lines which mean one place.
Yeah. Concurrency means they all meet at one point. Okay. So I told you about the I think I wrote the Euclid spelling incorrectly. Euclid is EUCLID. EUCLID. The first time I wrote it, I'm pretty sure I wrote it incorrectly. Euclid. Okay. Okay. Now, I really want you to understand these definitions. Okay, there is a major difference between these. Okay, there's something called a conjecture. Okay, there's something called an axiom or a postulate. I can provide examples for this. Okay, axiom or a postulate is an accepted statement. An accepted statement. Okay, in parallel lines, when I said that, hey, corresponding angles are congruent, did any one of you ask me why? Do we have a proof? No. We just accepted, it was said, and we have drawn parallel lines and we have seen that these two angles are equal. So we have accepted that statement that corresponding angles are equal, are congruent. That such type of accepted statements without proof are called postulates. Make sense? Whereas a conjecture is a mathematical statement. Mathematical statement. It is not an accepted statement. It is just a mathematical statement that is not an axiom. That is not an axiom. Axiom means it has to be accepted. The other name for axiom is a postulate. Okay. One big example is corresponding angles being equal in parallel lines is a very famous postulate or an axiom. That is an accepted statement. Okay. Now, conjecture is just a mathematical statement. Okay. It is neither an axiom nor we have not proven whether it is true or false. It can be proven true or it can be proven false. Make sense? It can be true or it can be false. We don't know whether it is true or false. It is just a mathematical statement. We can prove that it is true or prove that it is incorrect. Now, I can make a conjecture. Okay, let me make a conjecture. All prime numbers are odd. All prime numbers are odd. What is the mathematical status of this conjecture? Is it true?
Not true. Not true.
It's not true.
It's false. Why?
2.
Because 2.
Aha, 2 is the culprit, right? This 2, you know what is it called? It's in geometry, we'll start calling it as a counterexample. If you find a counterexample for a conjecture, then the conjecture can be proven false. Make sense? Counterexamples are one way of disproving something. Make sense? We'll study a lot of proofs in geometry, okay? But this counterexample, if ever you find a counterexample for a conjecture in geometry, that can disprove the conjecture. Or that can, I cannot say disprove, that can make the conjecture false. Okay, then what is theorem? Then what is theorem? You all know. Accepted statements with proof. Accepted statements, meaning it is one level more than axiom or postulates. Okay, but we have accepted them with proofs only. Make sense? Yeah. Can I move on? What is phi? Have you heard of the term phi?
Isn't it kind of like that?
Phi or phi, whatever. Huh?
Isn't it kind of like this or something?
Yes. But what is that?
Isn't it golden ratio?
Yeah, that's the golden ratio. Next week, can you all find out what is this golden ratio and come? I really want you to find out, okay? Before I do that, okay? It leads to golden ratio, leads to Archimedes spiral. So I really want you to understand what is this phi, what is this golden ratio, what is this Archimedes spiral and come. Okay, it is in the book.
Wait,
Okay.
the Archimedes spiral?
Archimedes spiral, sorry.
Okay.
Archimedes spiral.
Okay.
I don't know. I think they have it. This, yeah. See, the page number 1 of the book describes a spiral. Okay, but that's given as golden ratio spiral. Okay, I'll call it as golden ratio spiral. Okay, I should not confuse. Golden ratio spiral. Okay. So you're going to find that and come. Okay. Now, I also want you to get used to this website where I want to show constructions. For that, you need to get a little bit used to it. Let me tell you that text pad. I don't remember.
Priyanti,
Yeah, ma?
isn't pi also like 1 plus root 5 or something over
1
2?
plus root 5 by 2, right?
Yeah, or something.
I don't, yeah, yeah. So its value is 1.6, huh? True, but what is that significance of it is what I want to understand. You'll Google that and come, right? Yeah, that is right in your first chapter itself. Yeah, 1 plus root 5 by 2, 1.618, correct. Okay, but you know what? For the constructions, right? This is the website I would like you to get used to. Okay, it is mathspad.co.uk. Okay, mathspad.co.uk. Okay, so basically the thing is why I'm telling this now before we get started next week is if you just take this compass, it's very difficult. You should know how to move this, how to draw, all this you need to know. Okay, it's just a little bit of figuring out. Okay, meaning you can move by pressing on this by clicking on this violet color part of the compass, move it there and here. How do you draw? You go to the black thing on top, right? And then you hover over it or you click on it and then hover over it, then you'll be able to draw the arc. Make sense? So those are the things I wanted to get used to. Okay, now while I was doing this, right, I forgot to tell you in the circle, right, let me quickly share that with you. In the circle, right, suppose let's say there is a point A, there is a point B, there is a point C. Okay, now do you know what is this called? What is this called?
An arc.
Arc. But what is the difference between AB? Arc is like this. What is the difference between AB and ACB? Both are arcs. This is an arc, this is an arc. But what is the difference? This written with 2 letters is called minor arc. Okay. This is called a major arc. Major arc definitely requires 3 letters to be addressed as the major arc. Can I move on? We learned so many basics, right? Okay, one last thing. I just want to check up something. If you don't mind, you're going to wait. Okay. I just want to check up something. Then I'll let you go. Can we start doing alchemist? That's something I'm going to check now. Hold on. Because in parallel, if it goes, it's not a burden for you, is what I'm saying. If it doesn't go in parallel, we are not able to do anything, I feel. Okay. Oh, that's nice. How about this? Do you know what is the answer for this one? Couple of questions for you guys. Let's see. Do you know the answer for this one? What is X? What is X? Oh, am I not sharing? Sorry. Find out X. Quickly we'll do 5 problems, okay? 5 or 6 problems. Would be nice. I don't know. Sorry, let's see. How much ever we can do, we'll do. What is the X value? The second question is asking you for find ECG. These are all based on what we studied. We'll stop here, but we can continue next week. When you come back, just remind me to review these. We'll do 5 more questions. What is X? The arrows indicate that they are parallel. So it's all based out of what we studied. And the second one is asking for ECG. ECG. Okay. Should I do or will you do? Or we can do it next week as well. Whatever you want to do, guys. I will stop here. Hey, next week we don't have class, right? You don't know? No, that's why we are having the half hour extra class today and 18th. Next week we'll see. I have to travel. So yeah, I don't want to make a mess with the class. Internet being messy and stuff. You want me to show you or it's okay? We'll do it next week. I'm fine. Same problems I can bring up next week.
I did one. I'm just figuring out how to do two.
Which one? This one you did?
Yeah, I sent it.
Yep, this is 33. So this will be 180 minus 33. Makes sense? For this one, even I don't know. I have to think, okay? This is 46, right? 46 plus 39 is what? 85. So this is 85. So this should be what? Corresponding angles, 85. So this should be what? 105, correct? 105 plus 46, right? 105 plus 46 is
151.
So this is 29, right? So this should be 29.
No, the angle should be 95, right?
Which one, ma?
This one. This one.
Sorry, Vidyut, which one?
Wait.
Okay, tell me, explain, meaning, see here, I start here.
This one, it's like, it's supposed to be 180 minus 85, which is 95.
Oh, 95, yes, you're right, 95, thank you. 95, so 10, 14, 141, na 39, right? 39, let me check. Once I'll check. 39 is correct. Make sense?
Yeah.
So that's how, this is called angle chasing. Meaning in parallel lines, if you chase angles right, it's called angle chasing. The second one is angle chasing. Okay. Can I move on? Yeah. Both are angle chasing. The first one is very simple angle chasing. Second one is complex angle chasing. Okay. Can I stop here? Can I stop here, guys? Yeah. Bye, guys. That was good class. A lot of things pushed in. Bye.
Bye. Bye, Miss Priya.
Bye, guys.
Bye.
Bye, guys.